triangles. Okay, so time to learn about the most awesome shape ever. We obviously know a triangle has 3 sides and 3 angles, and we know they equal 180 degrees. So time to dig deeper. So when you have triangles, you can classify them, which means to name them, and you can name them by 2 things. You can name them by the angles, and you can name them by the sides. So when you name them by the angles, there are 4 different vocab words you need to know. So this is called equal angular. Think about equi, meaning equal, and then angular, meaning angles. So it means an equal angular triangle is a triangle where all 3 interior angles equal in measurement. So guess what? They all have to be 60, because 60 plus 60 plus 60 equals 180. So if you see a special triangle like this, it could be considered acute because all the angles are smaller than 90. But again, if they're all the same, they're going to be equal angular. Okay, so that leads us to acute, meaning all angles are less than 90 degrees. And then a right triangle would obviously be a triangle that has 1 right angle. And then an obtuse angle is where one of the angles is obtuse. Okay, so you can't have all of them. You just need 1 angle to be obtuse. Okay, so there's the 4 ways you can name something by their angle. And then if we move on, we can also name them by their sides. So equilateral comes from equi, meaning equal, and then lateral, meaning sides. So an equilateral triangle is a triangle where all 3 sides are the same. So they'll give you these little tick marks to represent that they are congruent. And notice it's also going to be equal angular. Okay, so equilateral and equal angular mean the same thing, except one deals with sides, one deals with angles. The other example is isosceles, and that's where 2 sides are congruent. So they'll give you these little angle marks right here. And we'll dig deeper into isosceles tomorrow. And then scalene is they're all unequal sides. Okay, so no side is the same. Okie doke, so that's how you name them. So why don't we look at some practice? So I've got A, B, C, and D. I want you to classify them by their angles. So give me 1 word, vocab word for that, and then give me 1 vocab word for sides. Okay, so try those, press pause, and then we will go over them. So for part A, I noticed that they were all 60, which means it's equal angular, and then all sides were the same, so it was equilateral as well. So equal angular, equilateral triangle. On part B, I noticed I had an obtuse angle, so that's an obtuse, and then all sides were different, so scalene. On part C, I noticed it was isosceles, and then I noticed all these angles were smaller than 90, so it'd be an acute angle. And then lastly, I've got a right angle, so a right triangle, and then all sides were different, so scalene. Okay, so that's how you classify a triangle. So let's look at an example. So let's find find D if RST is an equilateral triangle. So the first thing you know is if it's equilateral, I know all the sides are the same. So we could do this problem a lot of different ways. I just need to set one side equal to another side. So you could set D plus 2 equal to 12 minus D, or you could set 4D minus 13 equal to this one. Does not matter. I'm going to say 4D minus 13 equals D plus 2. Okay, so subtract D, 3D minus 13 equals 2 plus 13 on both sides. 3D is going to equal 15. So when I divide by 3, D equals a 5. Okay, so I've solved for D because that was an equilateral triangle. Okay. Example 4. I've got find X if ABC is isosceles. So I know that this side is going to be equal to this side. So this 2x is kind of irrelevant information. So I need to set x plus 9 equal to 3x minus 9. So the important thing is with sides, you're never going to equal anything to 180. They're going to have to give you some equal mark or something like that to solve for x. So first off, I'm going to subtract x and get 9 equals 2x minus 9. Add 9 to both sides. 18 equals 2x. Divide by 2 and x would be a 9. Okay? So again, we're done because it only wanted me to solve for x. It didn't want me to find the length AC or anything. But I could double check my answer and make sure that when I plug them back in that these sides would be the same. Okay, so that's how you find the length of a side if they give you two algebraic equations. But now we're going to look about angles. So the triangle sum theorem says that the sum of the measures of the angles of a triangle is 180. So we know that. So if I say A plus C plus B, I should get 180 degrees, okay? So let's look at some math. So I've got three little problems up here. We're just going to practice setting them up. First, so if it's a question mark, I don't know what it is, I would call it X. So algebraically, I would say X plus 135 plus 24 equals 180. Okay, you are more than welcome to do 180 minus 35 minus 24. And when I do that, I would get 21. So that little degree, the x would be 21 degrees. Okay, same thing here. I know that measurement is 90 degrees. So if I want to set up an algebraic expression, I would say 6x plus 60 plus 90 equals 180, okay? Basically, you need to make sure you're adding three things equal to 180. Once you solve for that, you would do 180 minus 90 minus 60. So you'd have 6x equals 30, divide by 6, and x would be 5. Okay, so why don't you try the bottom right one on your own, press pause, and then we'll go over it. For this bottom right one, I added all my angles and I equaled them up to 180. I combined like terms and got 190, and then subtracted that and I got negative 10, and that is okay to have an x value of a negative 10 as long as you plug it back in and you're not getting a negative angle. Okay, so 94 minus 10, that angle would be 84 degrees. And you can double check and say 84 plus 41 plus 55 does give me 180, so I know that triangle works out. Okay, so those are some pretty simple cases of the triangle sum theorem. Obviously, we've got some multiple step problems coming up. So we need to know our prior knowledge of angle relationships. So you need to know vertical angles. You need to know linear pair typically to solve these. Okay, so I'm looking for this question mark in the bottom right. However, I can't have two missing angle measurements. So with that 125, I know it's a vertical angle. So I can actually bump it in here and use it within my triangle. So now I have a triangle that I know equals 180, and I have one angle missing. So I can say x plus 125 plus 30 equals 180. Okay? Or do 180, subtract those two angles. So when you do that, you should get 25. Okay? So they're going to be a little bit harder because you're going to have to use your old vocab words to kind of move some things around. So right now, I have a completely blank triangle. I don't know any of its measurements. But I can bump 60 in here because it's vertical. And then I could find this missing angle based on that 150 because it's a linear pair. So I know a linear pair equals 180 degrees. So if I have 150 on the outside, I know I've got 30 degrees in the middle. Okay, so you're going to be using linear pair and vertical angle a lot in these multi-step problems. But now I can solve for this missing angle up top and say x plus 30 plus 60 equals 180. Again, or you could do 180 minus 60 minus 30, and you should get 90. Okay. So again, that's how you solve some multi-step problems with some numerical answers. Okay. All right, multi-step problems. Why don't you try these on your own and press pause, and then we are going to go over the answers, but try them on your own. Good luck. This one I got -8, and so my thought process behind it was I bumped in 20 here because it was vertical. I saw that this was a linear pair, so I did 180 minus 50 to get 130. And then you can't bump this equation in there because it's not vertical. So I used these two angles, and I did 180 minus 20 minus 30 to get me 30. And then I knew that this angle was a linear pair. So I said x plus 158 plus 30 equals 180. okay? Over here, could have done several different ways. I bumped 105 in because it was vertical. You could have also bumped in this equation in here because it was vertical and said this angle plus this angle plus this angle equals 180, which is what I did up here, and you should get -8 again. Or that I bumped in this 105 and I said 180 minus 105 minus 25 gives me 50 for this angle. And then you could have also said these are vertical angles, so I'm going to set them equal. And so lots of different ways to think about this. Down here I did a lot of math. So first off, I did a linear pair right here and did 180 minus 122 to get 58. So then I had a triangle, and I did 180, take away 85, take away 58 to give me 37 down here. I bumped 37 over here because it was vertical. I saw I had a linear pair right here, so I did 180, take away 134, which gave me 46. And then I had another triangle down here that I had 37 and 46. So I did 180, take away 37, take away 46 to give me this last angle of a 97. And then I saw that there was a linear pair, so I did 180 minus 97, okay, to get me 83. Now again, if that confuses you, please raise your hand and I will be more than welcome to explain that to you, because it was a lot of steps, a lot of problem solving. So on this one, I saw that these two angles were a linear pair. So I did 180 minus 85 to give me 95. I had to find this third angle of my triangle. So I did 180 minus 95 minus 40 to give me this angle. The trickiest part with this, to get over here, they're not vertical. You've got a linear pair, but you've got three angles. So I did 180, take away 45, take away 85. And that gave me 50. I bumped in this 80 right here because it was vertical. So to find this missing angle, I did 180, take away 80, take away 50 to give me this angle, which was a 50. Okay? So again, if you got some questions on those multi-step problems and my thought process behind them, I'd be more than welcome to help you. All right, we've got one more theorem, and it's called the exterior angle theorem. And it says the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. So, remote interior angles would mean A and B, okay, because they are the farthest from this exterior angle, okay? So the two angles basically not touching that exterior angle are the two remote angles. So I could say angle A plus angle B is going to equal ACD, okay? So my two inside angles plus this big outside angle will equal 180. So let's look at two problems. I'm going to do this one with you and then I'll leave this one to you guys. So I know that these right here are my two inside angles. So I would say 8x minus 4 plus 6x minus 10 is going to equal my outside angle of 140. Okay? So I combine like terms. 8 plus 6 is 14x minus 14 equals 140. I'm going to add 14 to both sides. So 140 plus 14 is 154. And I got 14x divided by 14. So x equals 11. Okay? So that's how you set up when you know two inside angles and the outside angle. So why don't you go ahead and try this last one on your own. Press pause and we'll go over it. Remote interior angles were 80 and 5x minus 10, so I added those together and set them equal to my exterior angle. Combine like terms. Right here I had variables on both sides, so I decided to move my 5x over here and then add 2 to both sides, and you did get 12. Okay, so again, we have to do this because I can't move this angle in here to get something that adds up to equal to a triangle. Okay, so if you know the two inside angles, they'll typically have variables. And you know an outside angle that typically might have a variable. That's when you're going to use this theorem of the exterior angle theorem, okay? All right, so now you get to practice. IXL is amazing. We've got F1, F2, and F3. Thank you for watching.